And this is the 1996 AIME problem 11. Here's the view of this problem. Let P be the product of the roots z to the 6 plus z to the 4th plus z cubed plus z squared plus 1 is equal to 0 that have positive imaginary part. And suppose that P is something in polar form, where the magnitude is greater than 0 and the argument is between 0 and 360, not inclusive 360. And we want to find theta. Okay, good. So now let's first look at this polynomial. Z to the 6th plus z to the 4th plus z cubed plus z squared plus 1 is equal to 0. Now whenever we see a wacky polynomial of some sort, we want to kind of make it to something we're more familiar of. So we see that we have like 3 consecutive z terms. That maybe makes us think of the roots of unity. Specifically, if we add a z term, then we get z to the 4th plus z cubed plus z squared plus z plus 1, which we know is z to the 5th minus 1 over z minus 1, the 5th roots of unity besides 1. So maybe we can do that. Actually, let's do that, right? So z to the 6th plus z to the 4th. All we're doing here is z cubed plus z squared plus 1 plus. Now we want to add a z, but we also want to remove the z to the 6th term, because this z to the 6th term is annoying. So we do this. But of course, what we do to the left-hand side, we have to do to the right-hand side. So this is equal to z minus z to the 6th. Let's apply basically what we did here, meaning that z to the 4th plus z cubed plus z squared plus z plus 1 is equal to z minus z to the 6th. Now the first image that we have we're doing something right is that this factors nicely, and this will give us a 1 minus z to the 5th in the factorization, meaning that we have some z to the 5th minus 1 terms. So let's just rewrite this as z to the 5th minus 1 over z minus 1. If you're familiar with roots of unity factoring, this is an immediate observation. Otherwise, you can just rewrite this as a geometric sequence and apply the formula is equal to z times 1 minus z to the 5th. Equal, right? Okay, let's just algebraically manipulate this. Z to the 5th minus 1 over z minus 1 minus z times 1 minus z to the 5th over 1 is equal to 0. And then we can multiply, get a common denominator and multiply this by z minus 1 to get z to the 5th minus 1 minus z times z minus 1 times 1 minus z to the 5th over z minus 1 is equal to 0. Now we can multiply by z minus 1, but then we notice that if 1 is a solution, if we get 1 as a solution to this thing, then it's not really a solution because this makes it an indeterminate denominator. So let's just leave it like this and maybe just expand this part. Factoring a z to the 5th minus 1, we get 1, and then this becomes, when factoring out a z to the 5th minus 1, this becomes a negative 1 that combines with this negative 1 to become a positive 1. So 1 plus z times z minus 1 over z minus 1. And then now this is probably very familiar territory. This is just z to the 5th minus 1 over z squared minus z plus 1 over z minus 1, and this is equal to 0. Okay, so now let's maybe list the roots of unity, and we need to make sure we follow the constraint that has a positive part. Positive imaginary part, meaning that the sign of the angle is in the first or second quadrant. Okay, so e to the 2 pi I over phi works. E to the, 36, yep. E to the 4 pi I by phi will work. E to the 6 pi I by phi will give us, it'll give us something not good, alright? It'll give us something where it's a negative imaginary part. So that's all the roots for z to the 5th minus 1 with the positive part. And remember, we can't have 1 because that'll make the denominator 0. And how about this thing? Well, this thing, it's pretty obvious. We can apply quadratic formula. Square root of 1 minus 4 by 2, which is 1 plus or minus I root 3 over 2. Oh my god, okay. So now, and then the only positive part will be 1/2 plus root 3 over 2i, which is e to the pi I over 3, right? Yeah, e to the pi I over 3. I think those are our 3 values that work, right? Yeah, looks good. I think now all we have to do is multiply them together. So we have, let's first add 6 pi over 5 plus pi over 3 to get 23 pi over 15, right? So our answer is e to 23 pi over 15. We just need to convert this now. 4, 3, 12, 23 times 12, right? So we get 230 plus 46, 276, and we are done. And perhaps I want to make some key observations because maybe we did some confusing calculations. These things were just the roots of unity for z to the 5th minus 1 that had a positive real part. This was the only cube root of unity that had a positive part. And then we're just, to find the product, we just add all the things. And then this is basically the same thing as the polar form, and all we need to do is find the argument for 276 and we are done.